Do you know why cats don't like closed doors? For the same reason that drives us to explore faraway space. We're anxiously waiting for the Voyager 1 and Voyager 2 spacecraft to leave the solar system. These twin probes have forged the depths of space for more than 40 years. But despite the fact that Voyager 1 is now located at a distance of 22 billion kilometers, or 13.8 billion miles from the Sun, and Voyager 2 is 18 billion kilometers, or 11.4 billion miles, they've only flown about 1,000th of the distance to the borders of the solar system. Even according to NASA's most optimistic estimate, Voyager 2 will need about 30,000 years to reach the outer border of the Oort cloud, a remote spherical region of the solar system where comets come from. But this doesn't mean we'll miss out on amazing discoveries, because the probes have already transmitted a lot of unique data to Earth.
Attention please. The Riddle Channel is connecting your device to receive signals from space. Do you hear it?
This is the sound of dense, vibrating plasma in interstellar space, which Voyager 1 managed to record between 2012 and 2013. Impressive, isn't it? Both craft, as before, regularly transmit data from the most remote region of the solar system, about which we know almost nothing. The first Voyager left the heliosphere, a conventional bubble inflated by solar wind plasma, as early as 2012 at a distance of 121 astronomical units, or AU, from the Sun. It was at this time that its sensors stopped detecting the direction of the flow of solar wind particles. The boundary of the heliosphere, called heliopause, is the region where the solar wind flow collides with the interstellar medium. The heliosphere is filled with solar wind plasma and its own magnetic field, and outside the heliopause is interstellar plasma, interstellar protons with the electrons and the interstellar magnetic field. Interestingly, Voyager 1, after crossing the heliopause, found that some high-energy interstellar particles, along with an external magnetic field, penetrate the heliosphere a little. Voyager 2 crossed the heliopause in December 2018 at a distance of 119 astronomical units from the Sun, and found that the solar material leaked into the interstellar medium. That is, next to Voyager 1, interstellar particles moved inside the heliopause, and Voyager 2 detected solar particles outside of it. The very border of the heliosphere, as Voyager 2 crossed it, turned out to be thinner than Voyager 1 recorded. Scientists still have no answer why this is so, but they continue to work to solve this riddle. It seems that immediately beyond the heliopause, there's an area where there's still some kind of connection with the inner world. For now, this is all the project team has determined under the leadership of Dr. Edward Stone. After comparing the data, scientists came to the conclusion that the heliosphere and the heliopause don't have clear boundaries, and the line of contact does not remain constant, but moves back and forth along with the cycle of solar activity. Stone was very surprised and delivered the verdict, saying, "The solar system breathes, and this dramatically complicates the picture." How is this possible? Two spacecraft, overcoming the same boundary during their flight path, gave data so different from each other. Scientists suggest that the two space probes reached interstellar space at different periods of solar activity, meaning that conditions along the boundary were noticeably different from each other. Voyager 1 reached the interstellar boundary during the solar minimum, and Voyager 2 arrived during the solar maximum, a period of increased star activity. The difference in performance may also be due to the fact that Voyager 2 and Voyager 1 crossed the heliosphere boundary in different areas, one in the northern hemisphere and the other in the southern, with a time interval of more than 6 years. The Voyager's mission also confirmed the scientists' guesses that the plasma in interstellar space immediately behind the heliosphere is much denser than the plasma inside the heliosphere. In 2012, Voyager 1 recorded a slightly higher than expected plasma density just outside the heliosphere, meaning that the plasma was compressed in this area. Later, the instruments of Voyager 2 recorded a 20 times jump in plasma density and plasma temperature as measured in near-interstellar space. It reached 50,000 degrees Celsius or 90,000 Fahrenheit instead of the predicted parameters of between 15 to 30,000 Celsius or between 27,000 and 54,000 Fahrenheit. The behavior of the magnetic field at the edge of the heliosphere is also interesting. It was previously thought that the field outside wasn't related in any way to the field inside the heliopause. So scientists expected a sharp change in the direction of the magnetic field between them. But Voyager 1, entering the field outside the heliopause in 2012, shocked the entire world with data that the field directions are approximately the same inside and outside. The news was so unexpected that it even caused researchers to doubt whether the spacecraft really crossed the heliopause region. The pioneering craft also noticed a rapid increase in field magnitude, a rapid growth of the field strength by about 1.5 times. Voyager 2 confirmed the data. Within the limits of measurement error, the direction of the magnetic field doesn't change when crossing the heliopause. It was even possible to measure the magnetic field outside the heliosphere, which was surprising to scientists. Voyager 1 showed 0.49 times 10 to the negative 9th Tesla, and Voyager 2 0.68 nanoteslas, or 0.68 times 10 to the negative 9th power Tesla. This fact has yet to be explained to scientists. It's likely that the interstellar medium immediately behind the heliopause is perturbed and still feels the influence of the solar wind. So the value of the magnetic field in different parts of the heliopause may vary. There are also data on pressure at the boundary of the heliosphere and heliopause. The pressure turned out to be much less than what a person on Earth feels, but more than astrophysicists' previous calculations predicted. 267 femtopascal, or 267 times 10 to the negative 15th power pascals. The speed of sound waves was also established, passing through this medium at 314 kilometers or 195 miles per second. That's 1,000 times faster than sound travels through the atmosphere on Earth. Scientists have received invaluable data, but there's still a lot of questions on the most unexplored field of osmosis. Unfortunately, the Voyagers won't be able to answer all of them, as the period of their work is drawing to a close. In the mid-2020s, the plutonium battery of both probes should run out of power, and their transmitters will shut down. After a few years, scientists will begin to gradually turn off the Voyager's devices. What's beyond the boundaries of the solar system, these twins won't be able to comprehend. This border is located on the outermost edge of the Oort cloud, a group of small objects influenced by the gravity of our sun. And it extends to a distance of 200,000 astronomical units from the sun. But while our wanderers forge through interstellar space, humanity has a chance to uncover part of the mysteries of the heliosphere and heliopause. There will also be no photographs in the heliosphere and beyond, and there's nothing to take pictures of there, said Susan Dodd, project manager for the Voyager interstellar mission in NASA's Jet Propulsion Laboratory, or JPL. Engineers turned off the spacecraft cameras back in 1990 to limit device memory consumption. The last image of the Voyagers was the famous pale blue dot, a photograph in which the Earth can hardly be distinguished. Even after turning off all systems and running out of battery power, the Voyagers will continue with a completely different mission. In the event of an encounter with extraterrestrials, they'll represent earthly humanity, reporting where our planet is and who inhabits it. Data is stored on the surface of 2 fixed Voyager golden records, with a message for an extraterrestrial race in the form of recorded audio and video signals. Do you think the record will find a new owner? or face inevitable loneliness outside the solar system? And will our descendants learn the fate of the two Voyagers after losing contact with them? Please let us know in the comments, and we will continue to monitor the mission and hold our breath for it to last as long as possible. You'll make our wait easier with your like